So, every object with mass attracts every other object with mass in the universe with a force called gravity. And here we have an equation, F equals G m over r squared. So, the gravitational force attracts every other object with mass. So, a object with mass in a gravitational field will be influenced, alright? Looking at our equation, F is the force of gravity, G is Newton's gravitational constant, and that 6.67 number is written on your formula sheet, so don't worry about remembering it. The big M and the little m are just two separate masses. So typically you'll get questions where you have two planets and you'll be finding the gravitational force between them, or maybe two particles or something like that. So you'll be popping those two mass values in. Now, it doesn't matter which value is big M and which value is little m, they're just multiplied, so you don't need to worry about that. And then R is the distance between the two masses. So, let's get on to a question. So for this question here, we need to calculate the gravitational force that the Sun exerts on the Earth, given that the radius of the Sun is 1.99 times 10 to the 30 kilometers, and its mass is 6.95 times 10 to the 5 kilograms. The radius of the Earth is 6,380 kilometers, and the distance between the two is 1 astronomical unit. And an astronomical unit is 1.496 times 10 to the 8 kilometers. So, we are also given the mass of the Earth. Alrighty. To calculate the gravitational force, all we need to do is apply our formula. So we're going to have F equals G mm over r squared. Alright. So G, our gravitational constant, right, is 6.67 times 10 to the negative 11. Our two masses are 6.95 times 10 to the 5, right? And 5.97 times 10 to the 24. Now the radius between them is, the distance between them is 1.496 times 10 to the 8, but we also have to account for the radius of the Earth. So the distance between them will be 1.496 times 10 to the 8. And then we're going to be adding half of the radius of each. So half the radius of the Earth and then half the radius of the Sun. Alrighty, let's figure that out now. So we have 6.67 times 10 to the negative 11 multiplied by 6.95 multiplied by 10 to the 5, 5.97 times 10 to the 24. and we're going to divide that by 1.496 times 10 to the 8. And this gives us an answer of 1.84 times 10 to the 12 newtons. Alright, now let's get on to gravitational fields. So a gravitational field is a region around a body with mass. So when we say massive body, we don't mean like a really big one, we mean one with mass. For instance, a planet in which other masses feel a gravitational force. So we can calculate the strength of a gravitational field, and that is given by G equals Fg on M. So